I'll just say,
Oh, there we go.
okay, yeah, that works because we do need to record things. Otherwise, it's tough to do anything after the event. Yeah, lots of people coming through, so there is a lot of interest in this specific event. I'm gonna try
We're
and
still,
admit people.
we're still officially ahead of the official start time, so we'll definitely give it
We are,
a few minutes, and we're waiting for our sponsor as well.
yeah, and our speakers. So
Yeah.
Just out of curiosity, how many people signed up for this?
It was around almost 800.
Oh, wow, okay.
Although,
not everyone will come.
yeah, that's pretty typical, but also not everyone was screened in, I think.
Yeah. We do have some screening in place for people to get value out of this. Some technical background is highly helpful.
Nice. I didn't know that. Like, I didn't know there was a screening.
Yeah. People apply to recipe. Okay, 1 second. I think it's also helpful to just mute everyone on entry. I'm gonna figure out if I can do that after the event, because usually I set the tab for it to be automatic.
I think I did.
You did?
I think I did set that setting, yeah.
Okay, we have our speaker. That's really helpful. Hello, Stephen.
Hey,
Yeah,
I'm very, very happy to see you here because without you, there is really no session. It's just us talking.
yeah, sorry, I've been here a few minutes. I've just been quiet. But yeah,
Okay.
good to see you.
Yeah, I'm just in 3 different screens doing 3 different things. So yeah, maybe Joe, you can chat with Stephen. I'm going to do some testing for live streaming, and we'll get started in a few minutes because it will take me time to admit everybody.
Yeah, so we'll hold on officially kicking things off because there are so many people registered and we're just at 9 a.m. Pacific just now. So I'm sure we'll give them the MIT time, the 5-minute grace period to enter late and still be on time. So I don't know if the MIT time is still a thing or if that was just where I was at MIT 20 years ago, but MIT time was definitely a thing.
I believe it's still a thing, yeah.
Good. What's the weather like in Boston?
Oh, good question. So I'm not sure. I'm not currently in Boston. So you can normally find me at MIT. But for the moment, I am on temporary leave from MIT and I'll be back in the fall. But I'm currently in London, which means it's 5 p.m. here. So it's kind of like a good end of day kind of meeting.
Okay. And I will be in London for one day probably. In just a couple of weeks, the end of April. We should have a coffee if you've got time.
Yeah, nice. You should email me. I think it should be right here.
Okay.
Something like that.
I know where to find you.
Yeah. But I think my impression about London is the weather's usually just slightly less hot in the summer and slightly warmer in the winter. And other than that, it's just the same gloomy type of climate as Boston.
I think Boston has a little more snow than probably London. I know London and Seattle are very similar. And having lived in Boston for a couple of years, I can say it's a lot harsher in Boston.
Nice.
That digging out of the car in Beacon Hill with like literally frozen into the curb with parking tickets across the window, and you're like, I can't move the car, it's frozen. That's Boston is very harsh.
That's a good image.
Really cool. Oh, we got Thomas from Seattle. We got people from Columbia, Vishret from Toronto. Welcome everybody who's joining. Josh from Seattle. Elizabeth from Columbia. We've got Portland, Nashville, Boston, Mike Bird is here. Hi, Mike. Hello, Mike. We've got Berlin. Amazing to see people from all over the world joining. Edmonton, Warsaw. Are you coming to the AI Tinkers Hackathon with OpenAI in Warsaw?
Yes, I do.
Oh, right on. Got Atlanta, Montreal. I'll see you there. We've got
I have to say Toronto. We have Toronto in the
Toronto, Chicago, Paris, Los Angeles, India, Hong Kong, Switzerland, Zurich. Amazing. Stuttgart. Incredible. Miami. Isabella, welcome. Munich, Italy, Ann Arbor. Wonderful to see everyone. San Francisco. We actually have that Bay Area also. Of course we do. We have a couple.
Yeah, we'll need a couple more minutes, but maybe we can start with introductions because
Okay, and then Karan is
still
asking to join. Oh, that's a different wrong one. Hold on, it's like it's Zoom. Trying to get our sponsor the link. So just 1 second. Okay, he's there. Karan, are you there? Can you come off the microphone and say hello?
Hey, hi Joey, I'm here.
Oh, hey, good. I'm glad you made it on. This is our sponsor from Composio, who's incidentally mentioned in the paper. So I thought that would be an interesting person. Stephen's smiling.
Awesome. I'm glad we got it. I'm glad we got that one. Yeah.
yeah, it worked out. We're so grateful, honestly.
Yeah, it is exciting. Paper Club, the last 3 sessions have doubled the number of registered attendees every time. There's twice, but if that keeps going, we'll have more people than exist on the planet Earth here shortly, which is nice. But we did run out of our Zoom plan, and so having a sponsor who's relevant to the actual paper and the author, I think is the best possible sponsor. And hopefully we'll just keep that bar for sponsors forever. Someone who's incredible can contribute to the conversation in a meaningful way as they are a subject of the actual research. Pretty cool. So we'll
Yeah,
get to that in a minute.
and honestly, call to everyone here, by the way, if you want to sponsor, reach out to Joe or myself. It's new terrain for us, but I guess we are there now where we're officially sponsorable, and it helps us bring these events to you. So please do let us know.
Oh my. 131 on the call. I'm going to do one quick thing before we get started.
Oh yeah, the event call invite changed because we had to change our Zoom plan. My contact details, 1 second.
I'm going to email the link to the registered attendees just so they make sure they get it.
Good idea. Yeah.
Okay, so that email's going out and we're good. Cool. All right. So maybe we can get started. We're 6 minutes past the official start time. So shall we?
Yeah.
Okay.
Yeah. Let's do that.
All right. Do you want to kick it off for me?
You can start and then I'll jump in. I'm just meeting people.
Right. So welcome everyone to Paper Club. This is an initiative by AI Tinkerers, the global community of builders, meetups happening in over 60 cities around the world, curated to technical people, showing what they're building to others, and to Human Feedback Foundation, Elena's foundation, which she can explain. And she's also the organizer for AI Tinkerers in Toronto, one of our largest and most active chapters, and brought us this initiative, Paper Club, as an online event series where we can convene with the authors of interesting papers, having all read the paper, hopefully, and come with our questions to interact live and in person. And so we're really excited that you're all here today. I'll let Elena do her bit, and then I'll introduce our sponsor.
Great. So Elena, I am the executive director for Human Feedback Foundation, which is a nonprofit. We are part of Linux Foundation AI and Data, and we're focused on advancing and promoting human in the loop and human-centric AI and the more open future for AI. And so this is one of our initiatives where we are collaborating with AI thinkers, and in this case also hopefully it works, streaming it to Mozilla AI at the moment, to their Discord, to close the gap and maybe build a better bridge between research and engineering, strategically so we're all building for the future, but also discuss where the humans belong in the technical scheme of things, which is always interesting for us. Okay, over to the sponsor.
Yeah, and it's interesting you say to understand where the humans belong in this. Today, we're talking about where the agents belong, and literally they are. And our speaker, Stephen, his research is really about like, hey, as these agent systems are deployed in increasing numbers, I think we're at the beginning of a very sharp exponential growth curve in that. It's like, hey, it'd be great to understand where they are, how they're built, and what they're doing. And this is the first such work, I think, to assemble that. So we're really honored to have you here, Stephen. One of the documented agent systems that is in the research paper is a system that was built by a person who's also on this call, who's our sponsor, Karin, from a very cool company called Composio that I've actually used a bunch. And I think it's incredibly relevant for anyone building agentic systems. They effectively make it easy to connect to lots and lots of systems, whether it's to provide retrieval sources for a system, like kind of grounding, but in different other than search, or it's to access actions. Like agents are interesting when they can do stuff. So if you want to make a calendar request or read your email inbox or kick off a process or post to Slack or whatever, Composio is a platform that makes that super easy. But I'll hand it over to Karin to tell us more.
Hey folks, thanks Joey, by the way, for introducing me and Composio. I'm co-founder and CTO of Composio. We are building the communication layer for AI agents. So if you want your AI agent to talk and act on your email provider or your calendar so that you can have a scheduling agent at your firm, or if you want to manage your sales in a CRM via an agent and want to connect your agent with Salesforce, Pipedrive, etc., you can do all this via Composio. We manage the authentication, authorization, provide you good quality agentic tools so that like the agentic accuracy is high, and also convert those tools over time into skills for the agents. You might have heard the saying, developers are as good as their tools. Same goes with agents. So over time, when we see the patterns of how your agents is accessing the tools, we improve it for the agent so that the agent can perform even more higher abstraction level tasks, starting from, let's say, just scheduling the meetings to owning the meeting as well, end to end via skills. So yeah, that's Composio. We are like communication layer, the skill layer, the substrate for intelligence of future.
I have one question for you. Given that you have so many connectors to different systems and you have so many customers using it to build these emerging systems that do incredible things for people, these semi-autonomous agent systems, what are some of the interesting uses of Composio that you've seen? Like, where is the early traction in the market from your perspective?
We are a horizontal platform, as you know, Jimmy. So kind of it's across the board. We have a great number of personal assistants that are being built on top of Composio. So that means using tools like Gmail, Google Calendar, Outlook, etc. There are people building AI SDRs on top of Composio. So using CRMs, people enrichment softwares, etc. Using Composio. There are AI customer support agents being built on top of Composio. And now we have basically we have partnership with Cursor, Windsurf, etc. Where I think the new buzzword that came up like MCP. So Composio is the biggest managed MCP server provider. So a lot of developers are using Composio, their IDE. So they are they are developers wanting to connect to like essentially their apps like Linear, GitHub, etc., Slack, or directly via Cursor or Windsor, whatever they are.
Cool. Thank you. And thank you for sponsoring the first sponsor of Paper Club. It's super great to have your support and really cool that you're part of the research. Well, maybe we'll hand it over to Stephen and start the main show now to walk through your research. But very briefly, like, what is the Composio connection in your research?
So in our paper, Composio is one of the 67 systems that we index, meaning that it, AI agent index.mit.edu, we have a system card for the Composio agent, which I think is pretty cool. So shout out to Karan and Composio on this. And I'll be talking about that and the other 66 agents and some high level lessons that we've learned from all of this. Is it a good time to go ahead and get started?
Yeah.
Yeah. Maybe start with introducing yourself because a bunch more people joined, and then you can kick it off.
Absolutely. So, hi, it's really good to see all of you, like so many people here. My name is Stephen Casper, but you can just call me Cass. And normally I'm at MIT, but I'm on temporary leave. I'll be back in the fall, but I'm in London right now. So shout out to anyone in London on the call. But I'm here today to talk about some systemization of knowledge work that I did with co-authors, including Noam Colt, on a highly agentic AI systems. And I'm going to go ahead and do my best to just share my whole screen. And hopefully things are in presentation mode. Do they look good? Yes. Can you see the titles?
Yes.
Okay. Perfect. So you are all probably like familiar, or you've probably at least heard a few times about like how AI agents are a really, really big deal here. And there are a lot of really cool things that agents can do. And there's also a lot of hype in the ecosystem. And there's definitely a lot of like, disorganized, disruptive innovation kind of going on, which the AI Agent Index tries to cut through a bit. But I'm getting a little bit ahead of myself. The way I want to actually start out talking about like AI agents is to give a brief history of like all of AI according to Cass, right? So quite a long time ago, the state-of-the-art regime of advanced AI services was just full of GoFi or good old-fashioned AI systems. These are things that aren't necessarily based on like neural architectures like we're very used to today. But in the 20th century and in the very beginnings, or kind of ending in the 90s, but also extending a little bit into the 2000s, good old-fashioned AI was kind of dominating the AI paradigm. Then there's this second regime, which, I don't even know what to call this one, but it was happening between 1994 and 2012. In 1994, people started using simple neural networks to accomplish simple tasks like digit recognition. And that was kind of where things were at, or, what was exciting going on in that like couple decades stretch. But then in 2012, that kind of kicked off the CNN, the convolutional neural network regime, where people started studying vision. And this era kind of was kicked off by AlexNet, this particular convolutional neural network, and the ImageNet dataset, which led to people for the better part of a decade really kind of focusing work on a state-of-the-art AI stuff into vision models. But then we had the large language model regime kind of slowly take over, where starting in about 2019, when GPT-2 came out, we started having access to some pretty advanced, pretty cool, pretty proficient text generation models. After the language modeling era, which was just a few years long, we got into this kind of chatbot era where we are working with language systems that are no longer just models of internet text, but that are fine-tuned in order to be able to accomplish specific assistive tasks, right? This was kicked off by ChatGPT, as you might imagine. And now I think we're kind of transitioning into the last, or maybe the second to last kind of really big, paradigm shift in what it means to be a state-of-the-art AI system. And that is this new kind of like agency era, or this agency regime, where AI agents are kind of like the frontier and all the rage. And many, many people are building AI agents, not just Composio, right? So I'm going to talk a little bit later about 67 highly agentic AI systems that we indexed for a project. But there's also a fun website, and I'll bring us to it just for fun. If you want to add this to your notes, feel free. It's called Awesome AI Agents, which is a somewhat non-selective, extensive list of, systems that claim to be AI agents. And as you might notice, there are a lot of applications here. There are a lot of different products here that people are pretty excited about and using. All right, let's go back to, there we go. So this is one kind of like early notable attempt to systematize or basically list a lot of different agents that are out there. So there's just a lot going on. And now we probably need to start answering a question that's always the first question people ask me about this AI Agent Index project whenever I tell them about it. Oh, sorry. Let me skip to this slide because I want to talk about this. So what even is an AI agent, right? So it's pretty hard to define. We are emphatically not attempting to define what an AI agent is, but we are going to inevitably kind of like need to operationalize some sort of notion of what it means for a system to be kind of agentic, at least. And here we turn to some prior work. This is a paper called Harms from Increasingly Agentic Autonomous Systems. And they outline a few types of categories for things that roughly correspond to kinds of increases in agency, right? One thing that this paper mentions is the generality of a system's capabilities, right? If a system is only good at performing particularly narrow tasks like playing chess or something, we can consider it to be on a little bit of a less agentic spectrum as opposed to more. Under specification is another important notion when it comes to understanding agency. Under specification refers to how much structure is imposed or required on a system trying to accomplish a task, right? If there is a lot of structure, there's a lot of specification in how that task is supposed to be carried out, and correspondingly, a low level of agency. Something that characterizes a high level of agency is for systems to be able to choose among many different ways how to accomplish a particular task. There's also directness of impact, that is, directness of impact on the world. If systems are able to influence the world directly, we can consider them to be more agentic, or at least this paper does. And there's goal directedness, which is systems that are kind of focused on achieving particular goals. This one's closely related to under specification. And then finally, long horizon planning and action. That one's pretty intuitive. It was what makes the difference between an agentic system that's able to accomplish more complex things versus a simple reactive system like a chatbot that's able to only accomplish pretty short horizon things. And this is kind of a way of reverse engineering or reverse to kind of describing this like paradigm of agency that seems to capture what is making these systems so useful and what's generating so much like investment and research and engineering around them. And our goal with the AI Agent Index was to provide a systematic study of what the field of advanced agents really looks like. Because when there's a lot of fast-paced development, it's kind of hard to keep track of things in a very systematic way. So basically, what I'm about to talk about in so many words in the next few slides is we did our best to capture what is most interesting about the field right now. But I'll have a lot to say later in the presentation about how like this can be limiting. So what did we do, right? We had to define some sort of criterion by which we would consider a system to be highly agentic and which would make us want to index that system. And basically, what I have to say about this is, well, you have to draw the line somewhere. So let me tell you where we drew the line. We constructed a decision graph to help us decide if a system was basically of interest to the AI governance community and would make us want to index it. So our procedure starts as follows. We start with some sort of agentic AI system, with the agentic part being in quotes. And we ask our first question, and that is, can the system accomplish a diverse range of tasks? And does it have meaningfully higher degree of agency than ChatGPT 4.0? And we chose ChatGPT 4.0 because it's just a very widely used, minimally agentic type of system that is a chatbot, but can also use tools like searching the web. And it can also repose information it learns about its users, etc. There are some fancy but minor things that ChatGPT can do here that kind of contributes to its agency. And we use this as our baseline. So if the answer is yes, that's a good sign for it being agentic according to us. And if the answer is no, then we'll get to, then we kick things to another decision node, which I'll talk about later. But suppose the answer is yes. The second question we ask, is the system a product deployed for commercial or other consequential applications? Here, what we're trying to capture is systems that are economically important and potentially economically disruptive. So if the answer to this one is yes, we include the system. If the answer to this is no, we ask our third question. Is the system open source? If the answer is no, then it's not a product and it's not open source, so we're unlikely to index it. But if the answer is yes, then we ask if it basically could be a product with minimal modifications. And if the answer to that is yes, then we include it. And if the answer to that is no, then we get to our kind of final bubble, our final decision node. And that is where we kind of just critically look at a system that we wouldn't otherwise include, and we say, is there another compelling reason to track this system? For example, is it particularly informative case study, or is it exceptionally relevant to shaping the state of the art? If yes, we include. If no, we exclude it. We ultimately didn't end up using this last node very often to include systems, although it did happen a few times, mostly from announced but not yet released projects by very big labs. But this is what we did. And in short, what this is trying to do is just include systems that are products or include systems that are open source and could be used impactfully nonetheless. Right? So where do we get with this? There were quite a lot of systems that we did not include. And whether a feature or a bug, it depends on context, but there were quite a few systems that that were not included based on these criteria. And I think it's actually kind of worth talking about the many interesting kinds of systems that the AI Agent Index just wasn't designed to include, right? One thing is non-agentic models, things that, aren't really claiming to be agents, even though they might be really impactful or important. For example, there was a recent llama model which is multimodal and which is really good at language and really good at vision modalities, but it's not designed to do anything particularly agentic, so we never considered it in the first place. Other types of systems are unnamed systems. Most of the unnamed systems that we didn't include were kind of afterthought systems that were just kind of coded up examples of using a particular agent development framework in some online repository or library. So when a system didn't have a name, we found that to be a pretty reliable sign that there wasn't a lot of development effort put into it, and that it's just usually an example alongside some code base. Relatedly, are a lot of systems that are really important to the agent ecosystem that are development frameworks, and that are meant to help people build agentic systems. But unless those systems had a qualifying flagship named model, we did not include these development frameworks as the agents we are focusing on. That would be kind of a type error, a type disagreement. We also did not include systems that cannot open-endedly accomplish a diverse range of tasks. This one was a little bit subjective, inevitably, but we tried to be pretty liberal here. And an example of some systems that we did not include, though, is that there's actually kind of a little bit of an online genre of bots that integrate, or apps that integrate with your GitHub and you can use them to automatically resolve pull requests. And this is a good example of a whole genre of systems that we actually just did not include. There are also systems that do not have a meaningfully higher degree of agency than ChatGPT 4o. A whole genre of systems that this included were customer service bots, right? And that's not saying that customer service bots are not really important and interesting. However, they're usually pretty closely following scripts. So there's not a lot of under-specification in how these things are designed usefully, usually. And they generally don't have a meaningfully higher degree of agency than a system like ChatGPT 4o. We also excluded systems that are not open source or products. For example, some academic papers produced agents, but then didn't release source code for it. So we use that as kind of a sign that this kind of system is not going to impact the real world a ton compared to alternatives. And then finally, second to last, we did not include open source systems that could not be used competitively off the shelf. Some of these were just systems that are kind of old, where the code bases are 2.5 years old or something, and they haven't been used very much. That was usually what happened here. And finally, systems deployed after our cutoff date for the index, which was December 31st of last year. And unfortunately, this led us to not include a few pretty interesting systems like OpenAI's Deep Research or DeepSeek R1 or DOBA 1.5, which are pretty interesting nonetheless and might get included in an Agent Index 2.0, but did not make the time frame for Agent Index 1.0. So at the end of this, we were left with 67 systems. And the bulk of the project was all about collecting information of technical and regulatory interest for these 67 types of systems. And we use these to construct agent cards. And an agent, a card, is oftentimes used in the the documentation in open source or research literature to refer to a document giving structured information about some sort of system. So you'll hear about model cards or data set cards a lot, for example. Well, here we're introducing this notion of an agent card. And we introduced 33 specific fields of structured information that it's useful for an agent card to include. So I'm going to, in the next few slides, show a bunch of these gray boxes, overviewing what we included in agent cards, but I'm not going to spend too long on it because all of this information is available at aiagentindex.mit.edu. So just for example, if you want to follow along, you can go to this page right here. But let's go back to the presentation. All right. So an agent card has 6 big types of categories of information. The first is kind of basic information about the system, which basically just means kind of the website, a short description of what it does, what it's meant for, etc. The next thing that we include agent systems, systematic information on is the developer of the system. Things like the developer's website, and then its legal name, entity, country, safety policies, links to these things if they exist, N/A if they do not exist. We next talk about system components. This is, I think, one of the more complex kind of categories of information in the agent card, but it basically just involves like, all the stuff that gets, hooked together to make the system. So things like the backend model, things like information about what the observation and action space are, etc. Fourth, we have information on guardrails and oversight. For anyone who is particularly interested in like AI risk management or safety as an academic field, this might be the part of an agent card that you're going to be the most interested in. Fifth, we have results of evaluations, both ones involving like safety and risks, but also ones involving just the model's capabilities and like as measured by benchmarks and such. And then finally, sixth and last, we also compile some information on the agent's relationship with the broader ecosystem around it, like interoperability with other systems and information about usage statistics and patterns. And that kind of sums up the 6 categories spanning 33 different types of different fields of information we collected on each agent. And that's it. That's the agent index. We have 67 agents, including composios, and we have 33 fields of information per agent. And I want to say like a huge thanks to like the whole team of co-authors who worked with me over the course of months, kind of systematically compiling and checking and permalinking all this information so that we could make it available online for anyone here to use. So just to show you what we're working with, I can go back to aiagentindex.mit.edu. And if you go to this index subpage, it'll have all the information I just gave, but then, links to all of the systems that we index and the cards that were produced here. So if we go to, for example, Composio's software engineering agent, we have all 33 fields of information in all 6 types kind of listed out here online. And in addition to that, we also have raw data that you can download in the form of well, you can download it as a CSV, but this document lives as a Google Doc. And all in all, I can zoom out quite a bit. It's pretty big, and there are over 2,000 fields of information on all 67 agents here. So, whether it's technical or governance or I don't know, like linguistic analysis that you might be interested in, you might find it kind of interesting to look into. What this kind of data set that we've basically produced. One other thing I'll point about the website is that, since we collected over 2,000 pieces of information, you can probably expect that we made some mistakes. And thankfully, some people have pointed out some mistakes for us that we've been able to fix because we're committed to doing that. So if you ever have any comments about the agent index, please check out our Google form listed on the website too. And you can let us know if you want us to check on anything that we might be able to fix. So that's it. 67 agents later, we have this kind of structured framework to understand the AI agent ecosystem through the lens of these 67 agents that our flowchart said were particularly of interest, right? So we didn't just create this, right? That's the main product of this whole project, but I have some bird's eye analysis to offer everyone if you're interested, about what these 67 agents kind of suggest about the whole ecosystem in general. One thing that we can look at, for example, is just like the country distribution of agents that were indexed. And something that we were a little bit surprised by is that there's this overwhelming predominance of systems that come from the United States. And we didn't report on this specifically, but anecdotally, inside the US, I think maybe a plurality, well, certainly a plurality, maybe a majority of the US systems that we indexed were from California-based companies registered in Delaware, which is interesting too. Um, but what we have to learn here is that, there's a lot going on in the US, and governance frameworks that try to work with agents are going to be much more effective in the US in the near term, at least compared to other countries. There are very likely some biases too in how we ended up constructing these agent cards toward the English-speaking world. And in case we missed any highly agentic systems from um, other countries or like that were not developed in English, for example, that's part of what our Google form is. But we find a striking, much more than expected, like kind of bias toward US systems here. Um, we also break things down by academia versus industry, right? And I wasn't too surprised by this one, but it's still pretty useful to know. About 2/3 of the systems that we index are from industry, and about 1/3 are from academia. And we don't have a specific chart for this next thing I'll tell you, but as you might expect, conditional on this breakdown, one thing that we actually find a big difference about between industry and academic systems is that academic systems tend to more often be open source and tend to more often be better documented compared to industry systems. And again, not too surprising, but the agent index gives us a systematic way to like actually know this information as opposed to like suspecting this information, right? Another thing we looked at is just like what AI agentic systems are really used for. Pretty natural thing to look at. We kind of open coded our way into 6 different categories that we annotated each agent as falling into. Software, computer use, which is kind of the most general, universal information gathering, then research tools, robotics tools, and then other, which was just kind of catch-all, which had a bunch of cool random stuff in it. But we can notice that about 3/4 again of these systems fall into a particular category of software engineering and computer use systems. And something to learn about this is just like, what types of tasks seem the most like economically prominent that agentic systems are being used for. And it certainly seems like, software development and open-ended computer use are pretty interesting or are pretty prominent here. We also do some work geared toward governance people in particular, and especially people with kind of a risk management mindset. We look into transparency in one particular way, and that is by looking at, some key things about like just documentation and code that's available about agents. And kind of we define documentation pretty liberally. If systems have, much at all that is reported on, we check this box for them. But one thing we find out is that about half of systems here have code released with them, which is pretty useful from a development standpoint, although, not always the best for every system. I'm not trying to like, impose judgment on this. And we have about 70% of systems which come with some form of documentation, which is nice. Although, one could argue that in certain cases, having more documentation could be useful. But then this last bit of a high level analysis that we did might be kind of the most interest to people who are interested in AI in society. In contrast to how we find a medium or high level of, code availability, documentation availability, we generally find a pretty low degree of safety and risk management related information. So up top, we found out that about 20% of these systems have a publicly available formal safety policy. And of that 20%, most of that was from some of the really big labs, some of whom had multiple agents in the index, like, your Microsoft, your OpenAI, your Anthropics, your Google. Like they all kind of check these boxes, while lots of smaller developers and lots of academic labs like didn't. And I'm not necessarily saying they should, but I'm saying that they did it, and it's worth kind of taking note here, right? There definitely are certain systems that just don't pose big risks, and certain systems which you got to balance like how thorough your documentation is with how quickly you're developing them, right? In the middle, we found that 70.5% of systems had any mention of publicly reported external safety testing. And once again, as you might imagine, it was usually the big labs whose agentic systems underwent this. And then on the bottom, we found out that about 9.0% of these systems had publicly reported safety testing by the developer. So only slightly higher than external safety evaluations. And overall, I'm not trying to moralize too much about what's here, but I think it's pretty interesting. Well, not super interesting. I'd actually say it's kind of expected that, we see a relatively low amount of, due diligence involving safety-related issues involving AI agents, because the field is so quickly evolving, right? In a field with so much kind of like breakneck innovation, we're going to see a lot of moving fast and breaking things. And that's really nice from a lot of perspectives too. It means that we can like get a lot more done. But I think as the agent ecosystem both matures and the agent ecosystem gets full of systems that are, more economically and more than generally just powerful, it might become increasingly important to have higher standards of like safety documentation related to them. So that's basically my whole presentation on the AI Agent Index. And I'll probably try to wrap this up in about 5 minutes, but I want to take a few slides to just kind of talk about like my thoughts, what I have learned from this like months-long, semi-grueling process of indexing 67 AI agents. And one thing that we talk about at the end of the paper is, what are some things that might be kind of nice in the ecosystem? One thing that the numbers on safety kind of suggest is that like structured bug bounties to, kind of continue to sustain and cultivate a community of people looking for problems with systems so that they can be fixed. This is an all-around pretty good thing. And if governments or industries did more to kind of support this, probably about everyone is going to be a winner from that. More systematic testing of agents. We find a lot of holes in how agents are benchmarked or reported on, or at least, what's visible regarding all of this. So this could be really useful from a domain awareness kind of standpoint, whether you're a researcher like me or maybe someone in government. Centralized oversight of indices could be a useful thing. The AI Agent Index is actually a pretty small scale project undertaken by a bunch of academics, right? But one of the things that we wanted to do with the whole project was kind of pioneer a framework to systematically document information about agent-like systems. And we hope that more formal versions of indices like this can be incorporated into like government's frameworks or maintained by AI offices and governments or such. Finally, integration with model registries seems pretty important. Almost trivially, because model registries are talked about as a really kind of like low cost, high upside way of improving societies and governments' understanding of the AI ecosystem, and integrating that kind of thing with systematic, with like an agent card, could be pretty valuable. So I next want to talk about another discussion point about what some of the safety and security challenges agents really pose. And I'm just going to flash up these 4 papers on the screen, which I think might be good for anyone to jot down if you're particularly interested in looking at any of these, looking into any of these things some more. So these top 2 papers, I think, are really interesting, kind of like seminal papers in the study of agents and safety around agents. The agent harm paper and I'll just call it the University of Maryland agent red teaming paper. But both of these papers show something which is actually a little bit surprising and a little bit concerning from a safety and risk mitigation standpoint. And that is that, these agents, which are typically systems powered or brained or back-ended by, your typical chat bots like GPT-4o or something. These agents oftentimes, as a system that accomplishes long horizon tasks, much more willing to do harmful things and comply with harmful requests, many shot, compared to their back-end brains, one shot, which is really interesting. And I think a defining challenge in the safety of agentic systems going forward is going to be studying why agentic systems make more safety errors than their back-end systems do, and how this can be mitigated. Meanwhile, on the bottom of the page, the International Safety Report and the Governing AI Agents paper, these are just two other papers I would recommend for kind of like bird's eye view studying up, if you will, in order to get more familiar with the AI agent ecosystem. All right, we're getting close to the end, second to last slide, I think. But there's this other discussion slide, which it's been a long time coming. And if you asked me, Cass, what do you really think about the AI agent ecosystem? I would say, somewhat emphatically, though not pejoratively, like I think it's a total hellscape. And working on this project was really, really rewarding. Like, don't get me wrong, but it's actually a really like fantastically chaotic ecosystem to study it all. For example, I think personally the term agent is one that is just kind of rampantly abused. Lots of systems that we ended up not indexing were systems that were called by their developers agents nonetheless. Just because when you call something an agent these days, it's just kind of a term that is often used very cheaply to make it seem like something is really cool or worth hype, when it's really just kind of a chatbot or something like that deep down. Another like observation that I would somewhat like dramatically throw out here is that no one knows what's going on, right? One thing about the AI agent index is that I do not want the last thing I want is the fact that we index 67 agentic systems to remotely suggest that this field is one that lends itself well to taxonomization and indexing, right? We really kind of did this through sheer force of will, but there is so little infrastructure in the agent ecosystem to really systematically understand what's going on and what different kinds of capabilities and what different kinds of like integration and impacts to many different systems across the world have. Hype is off the charts. Um, this is kind of connected to how the term agent is rampantly abused. I want to say there's also fairly little transparency and understanding, and a kind of a rift between researchers and developers. And what I mean by this is that, if you are on the research side of studying AI agents, kind of academically, if you're someone a little bit like me, you're probably used to reading papers where, people benchmark a bunch of agents, where they look at this ChatGPT backend model and this Anthropic model, a Claude backend model, and that'll be the job of benchmarking that they do. And with whatever they're studying, usually papers are going to be pretty satisfied to kind of have checked off their like 5 or 6 minorly different agents that they worked with, and then proceed with their findings from there. And that's often fine, but it's just very striking how the research ecosystem focuses on such a microcosm of the agent ecosystem. Mostly open systems that are really simple to engineer and configure and study in a scientific way. But this is out of sync with the reality of how, in the industry side of things, there are so many different agents, which are just not all plug and play, which you can't study because they're not really nice model research systems, but they're being used really impactfully in the world nonetheless. And we can point to this as a kind of a cause of concern about how the research ecosystem might just be systematically challenged in its ability to really study agents in the real world. And this is now, earlier I wasn't trying to get opinionated, but now I am getting a little bit opinionated. Safety is kind of off the radar sometimes. A really good example about a recent system that should have had some more safety reporting on it, but didn't, and the developers have no good excuse, is the recent Gemini model 2.5, which I believe to this day was kind of pushed out a little bit more quickly than some people would have liked to, and never had a system card reported alongside it. To talk about like concerns, risk mitigations, due diligence, etc. So last slide, lots of people ask me, well, you cut off on December 31st. Is there going to be an agent index 2.0? And my answer to that is hopefully. Hopefully by December, January of 2025, 2026, we can get back and update the AI agent index. But one important thing about if an index 2.0 happens, it's going to be a very different type of index. Because one thing that we found, including just over the course of making the AI agent index, is that there were more and more agents that met our criteria every month that were kind of getting released. For example, here is our histogram of release dates for the different agents that we worked on. And as it turns out, more than half of them came out during the last few months of 2025 when we were 2024 when we were actively indexing these systems. So, the threshold for a good index in 2024 is not going to be the same thing as a threshold for a good index in 2025. So if we do make an agent index 2.0, which we want to do, we're going to revisit this flowchart and substantially tighten the criteria for inclusion in the index so that we can continue to do our best to put our focus on frontier systems that might be impacting the world quite a bit. And with that, that's all the slides I have. And I'm glad it looks like there's another 13 minutes until 1 p.m. And I am really happy to take any questions or discussion in whatever method that Elena and Joe would recommend.
Wonderful. We'll definitely open up to the floor. People can unmute and ask a quick question. But thank you so much for your time today, and to Composio. You mentioned that AI is a total hellscape. So I'll just shout out Composio is your solution to avoiding that hellscape. I had to do that, you guys. Thank you so much. On the question, I'll start off with the first question. You mentioned the index 2.0. You talked a little bit. If you were to do that index, how would you do it? This is a space that's my joke about the AI Tinkers community, and I'm only half joking, is there's probably 3 new agent frameworks at every meetup we do. It's an exponentially growing field. There's lots of experimentation. There's more hype than reality yet, but it's coming. How would you possibly update an index that's growing exponentially? Would you use agents for that? Have you thought about that aspect?
Yeah, I think this is a really good question. And something I especially like about this question is that it mirrors a really big parallel problem that governance has, right? And there's a problem that's being debated in like California and Illinois right now, for example, right? You know, thresholds are really important in the AI ecosystem, not just for people systematizing knowledge of the field like us, but for people, trying to regulate the AI ecosystem, right? And it's always a big challenge to try to pick what systems are included and what systems are not included, right? And some themes related to this challenge are kind of the importance of updating thresholds over time, which we're experiencing, and which lots of people are saying is going to be necessary in states like California or Illinois that want to like regulate certain systems or certain developers based on like cost or compute thresholds and stuff like that. But to get straight to your question, like what kind of things do we envision including? Um, I think if we did an agent index 2.0, if you like forced an answer out of me right now, I think we would threshold inclusion in the system by um, developer, not by model or not by agent. So we would say that all agents created by particular developers um, who meet these standards are going to be included or indexed. And one nice thing about this is that it's a very objective way to try to kind of like operationalize inclusion. And another nice way to do this is that, you could probably notice from the slides, one of our goals with AI Agent Index was facilitating regulatory awareness of these systems. And if we're trying to support like good governance of AI agents in the future, there are a number of reasons why governance interventions and regulations might want to target kind of the big guys in the space, as opposed to just kind of smaller projects that are being undertaken sometimes by like academic groups or small startups, etc.
Great. So we'll have Alyssa go next and then Daniel Brown.
Thank you so much. This was really fantastic. I'm the director of AI Trust and Safety at AMIA Research Institute in Canada. So love to see this. And we're building out a focused research domain in AI trust and safety. And your mention of the fact that AI agents make more safety mistakes is super compelling, and it's a little bit off the radar. So my question is, if you were to focus on a few key research problems in this area, where would you think about it, or are there specific problem definitions in this space that would be really meaningful for the field?
Yeah, I think that's a really good question. It's a very similar question to asking me, oh, Cass, what are you thinking about with agents next, right?
Yeah.
And Noam Colt and I, who are kind of the two, front seat passenger, like driver seat, passenger seat people for this whole index project, we've been thinking about not just an agent index 2.0, but we've been thinking about some systematic analysis of like terms of service and acceptable usage policies from different developers. We think there's some interesting like boring, potentially boring, but interesting to different people. Findings here related to like law and governance,
Mhm.
things worth systematizing in the field. We're also kind of interested in more generally this paradigm of like law following AI, because, and this is something that Noam in particular is interested in. This legal dilemma posed by, you know, agents doing things of significant consequence in the world, not just being humans anymore, right? And there's a lot of, I think, kind of empirical and a bit of philosophical work to do about this paradigm of like law following AI and AI agents in the legal system. So these are a few interesting things that come to mind for sure.
Great.
But I would also, yeah, like I would also be encouraging to anyone who just kind of wants to look through the columns of our index, look through the fields of our index and, see what things might be kind of interesting to you to kind of, look at in a latitudinal way about the ecosystem and then kind of get interested in anything you want to, look into more. One thing that I would hope the index is useful for is this kind of like way of facilitating people's, quick and dirty exploration of the field for things to into more.
Okay, Dan, you're next, and then Igor Pavlov and Eric Wood.
Thanks so much. And this was a really great presentation. And I was aware of the paper before because I work at the Schwartz Riesemann Institute at U of T. So Noam Colt is a colleague of mine. And so I was really interested to see this presentation. So the question that I want to ask is about application domains and adoption. And so it's sort of been noted in the past that there's this tension between the efficiency of these platforms and incumbent platforms. So if you think about ChatGPT being substituted as a search engine, everybody's concerned that it means it bypasses traditional search engines and, in fact, many people's websites. And this is only more pronounced with agentic tasks. So, for example, if Siri were to ever get good enough to actually get an Uber to show up for me, it would mean that I wouldn't have to ever open that app. So it would seem that those incumbent apps would be actually opposed to potentially efficient agents because it would be bypassing them. And I'm wondering if you might have any comments on this tension with regards to trends in what you've seen with application domains.
Yeah. Anyway, I like the way you're kind of thinking about this and modeling the disruptiveness of systems like this. Um, and I think you make good points here, like already. One thing that comes to mind though about like how, agents are really integrated into, or agents really kind of work. Where is this? This slide, right? Here we gave like the coarsest possible breakdown of like agents by application domain. And I want to kind of draw some attention to this universal slice of the pizza, this one in yellow. And when I was presenting, I actually kind of went over this a little bit quickly. But the systems that are, compose this universal slice of pizza, it's OpenAI 1, OpenAI 3, Claude 3.7 computer use, or maybe that one's in the computer use one, but the DeepSeek V3 falls into here. What I'm getting at is this like small yellow slice of the pie with these like universal agents is actually like a much bigger fraction of the ecosystem or the traffic compared to what this figure suggests. And one observation, kind of hopefully related to what you're saying here, is that this is a space that's kind of dominated by a few systems that are able to do quite a lot of things. A few years ago, if you ask someone about like what the, rise of AI agents might look like, you might expect that, they would suspect that there would be different companies that made agents that were really specialized in different things, right? And there is this to some extent, right? Like I see ads on YouTube sometimes about like that legal advice AI agent or something, which is like a chat bot prompted to like speak in legalese, right? But I think it's pretty notable that, there are a few systems that kind of, crowd out lots of niches in the ecosystem just by being so general purpose, right? And maybe this is the best I can do in kind of sharing some impressions here. I think that when we kind of model the disruptiveness of AI agents, we need to do so in a way that kind of respects the outsized impact of a few very general, very influential, very large systems from very large developers. And this is actually one way in which the space is, for intents and purposes, probably a little bit more anti-competitive than it might seem based on how big it is and how many agents are out there.
Sounds good. Igor, are you ready to ask your question? If not, Eric, you can go next.
Yeah, sure. Thank you so much for the great presentation and the study. I have a couple of questions if there's time for that. My first would be, did you actually do your study based on the available documentation, or did you also do some validation testing to test the agents and their behavior capabilities?
Yeah, great question. So in our case, we focused on publicly available information, and we did not conduct any experiments of our own. Although that would be a type of project I would be quite interested in. I think there's one out of Princeton that tries to take a smaller set of agents and kind of compile, like systematically compile their results on different types of benchmarks and stuff. So I think this stuff is really cool too, and I'm glad that there's this Princeton group working on it. One other way we got information sometimes for the AI agent index is through contacting developers and asking them for, feedback and corrections on the agent cards that we constructed for them. I think we had a response rate here of about 36%. And sometimes developers gave us corrections, which was pretty nice. But a few times developers tried to give us information that was not publicly available, and we just told them no, sorry, we can't we can't add information here, even if it's true, even if you're telling us, unless there's some sort of public reference link for it. So those are the details about where we got all the information and on what basis we put it up in the index.
Okay, that's Eric related to your question, right? Is that answered now?
Yeah, my question's answered. Thank you.
Okay, great. Manal, you had your hand up. I'm gonna try and unmute you. Second.
So much.
Yeah.
Oh, sorry. I have my
Go ahead.
found, but anyway, quick question around your agentic thinking. So I know in the paper you had talked about various ways to frame agents, and a large part of your database here focuses on LLM-based agents. There's been a lot of reinforcement learning agent work, right? As well, and there are agentic systems that already operate within enterprises based off of reinforcement learning principles driving the actions, right? So, and they're good in continuous learning and etc. I'm just wondering if you're seeing, in addition to the multimodal, are you seeing multiple approaches and fusion of various approaches to agentic frameworks now also starting to emerge in, or are you just really focused on LLM driven agents?
Yeah, I think that's a great question. And I think I might want to kind of split things up and talk about two things that are a little bit separate. One is this kind of RL paradigm and what it can do with LLM-based systems, right? I think it's become quite clear in the past few months, past year or so, that some of the stuff that frontier labs are scaling up the most on is this RL post-training of systems, right? One of the things that we have the most transparency about is DeepSeek R1 recently, which has undergone with very impressive results, relatively cheaply, so they say, RL post-training to give it some pretty advanced capabilities. So, that's half of my answer about the role of RL systems in the LLM world. But you also bring up this point about how there's so much that RL-based systems are doing that are not necessarily just large language models, right? And there's a really long history of really cool stuff happening in the AI research space here. If you can think back to AlphaGo and systems that do really well in games, and systems that drive cars, and systems that work pretty well on what is it managing jobs on servers and stuff like this, scheduling things like that. And these are not systems that have a high degree of underspecification. So we generally did not include most of these types of things on the index, although there are a couple of exceptions, there are two robotic systems that we included in the index. But I think pointing out these systems is one example of how, just because something is not in the agent index does not mean that it is not an influential, our agentic system, depending on your definition of agentic. So I hope that answers the question.
Oh, great. And then Abhishek, do you want to do the last one? And then we're going to wrap up because we're at time. Okay, I guess we'll wrap up then.
Awesome.
Anyway, thank you everyone so much. Great to talk.
Thank you, Stephen, for joining us and walking us through. Thanks everyone for joining this event. We'll hope to see you at the next one. And do send your feedback. Look for the survey link. Provide that to us. It makes us iterate and get better. So thank you for engagement. And thanks, Elena.
Yeah.
Thank you guys.
Thank
Very
you.
informative.
Thank you.
Yeah. Please, reach out for sponsorship. Like I said, actually relevant and proven, and you can see how much value it's a great discussion here. We'll see you very soon again. And as a reminder, our theme for this series is agents. So we'll get a lot more interesting papers. And Cass, thank you so much for the presenting. You're back in this room. You've been here before, and it's great that you have done work relevant to the human feedback series in the fall and now agent theme in the spring. Fantastic to have you back. Thank you everyone for joining. Thank you. Bye.
Thank you all. Bye.